Hello class, welcome to Pre-Algebra lesson 11.4 and 11.5. Today we're going to talk about angle relationships and triangles. Okay, so by the end of this lesson you should be able to classify triangles based on angles or sides, and you should be able to find the measures of interior and exterior angles in a triangle. Okay, so first I have just some vocab for you. You can see I'm going to make this just a little bit smaller so it all fits on one screen for you guys. So there are a few different ways to classify triangles. So up here, we're talking about by angles. And this is something that you guys have talked about back in like elementary school, and you maybe haven't thought about it since then. So let's just review. So a triangle can be classified according to its angle measures. An acute triangle is a triangle with three acute angles. So let's remember that acute means that it is less than 90. Less than 90 degrees in order to be acute. An obtuse triangle is a triangle with one obtuse angle. So obtuse means greater than 90 degrees. Okay, and then a right triangle is a triangle with one 90-degree angle. Okay, so that's how you classify by using angles. And then you can also classify triangles using its sides. So down here, this is all about the sides. Okay, so a scalene triangle is a triangle with all three sides of different lengths. Okay, an isosceles triangle is a triangle with at least two sides of equal length. And then an equilateral triangle is a triangle with all three sides of equal length. Okay, so these 6 items, acute, obtuse, right, scalene, isosceles, and equilateral, are things that you need to make sure that you have memorized for the upcoming test, or make sure you have it on your note card, okay? You need to be able to classify triangles based on their angles and their sides. So let's look at some examples. So here I have like a little diagram showing you the very top row here, starting in this box. You can see that this is an acute triangle. All of its angles are less than 90 degrees. Remember, a 90-degree angle looks like this, okay? So that's our right angle. Okay, so our first triangle is acute, and then the three sides, none of them are the same length. Some of you might look at that picture and say, well, Miss Johnson, it doesn't look like they're that far off. Like maybe 2 of them are the same. Well, if we move over to the right and look at this triangle, notice that we have 2 little pink markings on the 2 of the sides of this triangle. Those little pink markings tell you that those sides are the same length, okay? So you can't assume that sides are the same length unless they have those markings, okay? So the middle one here is an isosceles acute triangle. All of its angles are still less than 90. And then over on the far right, we have an acute equilateral triangle. So you can see that we have 3 of the pink markings. That means we have 3 equal sides, and none of those angles are bigger than 90 or even 90. So those are the top row here is all acute triangles. Next, let's look at our right triangles. So this first triangle here, we don't have any of the pink markings, the tick marks on the side length, so we can't assume any of those are the same length. So I'm going to classify that as scalene. And then if I go over to the right, I have 2 tick marks that are the same, and a right angle marking, meaning this is a right isosceles. And then you actually cannot have a right triangle that is equilateral. That can never happen. And we can kind of talk about that later. But then let's move on to obtuse angles. So you can see that we have this angle right here is obtuse, that's bigger than 90 degrees. And we don't have any pink markings, so this is scalene. Then here we have 2 tick marks, meaning those 2 sides are the same length. So we have an obtuse isosceles triangle. And then you cannot have an obtuse equilateral, okay? So hopefully that makes sense. Now let's practice classifying triangles by its angles and its sides. Okay, so if we look at this first triangle, you can see that we have 3 angle markings that show that those 3 sides are all, or 3 angles, sorry, are all the same. And they are all less than 90. So this is an acute. And then when you look at this triangle, we don't see any tick marks. But since we know that all 3 angles are the same, we also know that all 3 sides are the same. So that's another way to tell if it's an equilateral. So if all of the sides have the tick marks, it's equilateral, or if all of the angles have the same marking, it's equilateral. Okay, let's move on to the middle one. We have a right angle, sorry, let's start there. We have a right angle, so we would say right triangle. And then we have 2 sides that are the same, so that means it is isosceles. And then moving on to our last one, I have 3 sides that have tick markings, but do you notice how this side has 1, this side has 2, and this side has 3? That means that they are all different lengths, okay? So this is considered a scalene. And if I look, I have an angle that's obtuse, so I would say obtuse. So it is an obtuse scalene. Okay. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Now I want you to try this problem on your own. Classify the angle by its sides and its angles. Good luck. Okay, for this problem, hopefully you said all of the angles are acute, they're less than 90, and we have 2 sides that are the same length, so it is isosceles, making this an acute isosceles triangle. Okay, so if you have questions about that, please be sure to reach out for some help. I am happy to help you. Let's move on to just like some quick vocab on kind of like naming some parts of triangles. So if I look at this very top row here, you can see it says side, side, side. Okay, so let's practice naming sides of triangles. If I look at this first one right here, I see that I have the side that's highlighted green contains the letters X and Y. So the way I would name this line of the triangle, the side of the triangle, I would say X, Y, and then I put a line over it to tell me that it's a line segment. Okay, so then the middle one, the top middle here, I see I have Y and Z, and I put a segment mark over it. And then my next one, I see I have X and Z, and I put the bar over it. So I have segment XZ, segment YZ, and segment XY. Okay, so that's how you name sides of triangles. And then moving on to the next row, we're talking about vertex. So vertex is just like what angle is highlighted. In this case, angle X is circled. In this case, angle Y is circled. And then in this case, angle Z is circled. So for the vertex, you get to just write whatever letters at that point in the triangle. And then our next example, we're talking about angles. So if I look at this picture, I see that there's an arrow pointing at angle X. So I draw my angle marker and I say X. My next one, I see that I have angle Y. And my last one, I have angle Z. So that's just how you name the sides, vertex, and angle on a triangle. Okay, so if you have questions about that, please be sure to ask for some help. I'm happy to help you. Let's move on. Okay, so now we're talking about how to find all of the measures inside of a triangle. So the sum of measures of the interior angles, so all of those angles inside a triangle, is always 180, okay? So you know that you can add your three angles together and they will equal 180. And that's really helpful because sometimes we don't know what an angle measure is, so we'll set up an equation and solve for it. Like in this example, we want to find the value of x in the flag of St. Kitts and Nevis. So if I look at this triangle, I see I have the triangle going like this, and I want to solve for x. Okay, so in this triangle, I see I have a 56-degree angle. So I'm going to say 56 plus another angle I know. Doesn't have a number written, but it has this marker right here that tells me it is 90 degrees. So I'm going to say plus 90 plus x equals 180. So if I do 56 plus 90, I get 146 plus x equals 180. And then I can do 180 minus 146 to find out that that measure of angle x is 34 degrees. And I'm done. Okay, so there are 180 degrees in a triangle, and you just set up an equation to solve. So now I want you to find the value of x in the doghouse. Good luck. Okay, for this problem, hopefully you set it up, x plus 86 plus 47 equals 180, and then you ended up with x equals 47 degrees. If you have questions about that, please be sure to reach out for some help. I am happy to help you. Well, let's move on to the next example. So now we're going to practice using ratios to find angle measures. In triangle ABC, the measures of angles A, B, and C, respectively, are in the ratio 1, 4, and 5. Find the measure of each angle. So if we are looking at something like this, when you see that word respectively, what that means is, since this is in order A, B, C, that means this is in order A, B, C. Just so you know, that's what that respectively means. Now, how on earth do we solve this? Like, I don't see really like any angle measures. I just see a 1, a 4, and a 5. But how do I do this? So, in order to find angle measures using ratios, we still start with, we know it all adds up to 180 degrees in a triangle, okay? And since we don't know what angle A is, we use a 1x. And then I say plus angle B, which would be 4x, plus angle C would be 5x. Okay, so when you're solving for ratios, you add x's in with your numbers, and then you add them and set them equal to 180. That's how you solve. So now, if I continue on here, I have 1 plus 4 plus 5, or 10x equals 180. And then if I solve for x, that means I have to divide both sides by 10. So divide by 10, divide by 10. I get x equals 18. Okay, so now I know what x equals, but I want to find the measure of each angle. So the measure of angle A equals x, right? 1x, so that's just 18. The measure of angle B equals, I would say, 4 times 18. And 4 times 18 is 72. And then the measure of angle C equals 5, right? 5 times 18. So 5 times 18 is 90. And then I can test that out. I can say 18 plus 72 plus 90, that equals 180, so I know I solved it correctly. Okay, so that is how you set up a ratio problem and solve it. Okay, if you have questions about that, please be sure to ask for some help. I'm happy to help you. Otherwise, go ahead and try this problem on your own. We have in triangle LMN, the measures of angles L, M, and N, respectively, are in the ratio 1 to 5. Find the measure of each angle. Good luck. Okay, when you solved this problem, hopefully you found that the measure of angle L was 22.5, the measure of angle M was 45, and the measure of angle N was 112.5. Okay, so the way I did that was I set it up as x plus 2x plus 5x equals 180, which when you combine all of those x's, that's 8x equals 180. And then you divide both sides by 8, and you get x equals 22.5. Then you just have to do 22.5 times 1, which is just 22.5 for angle L, 22.5 times 2, which is 45 for angle M, and then 22.5 times 5, which is 112.5 for angle N. Okay, so if you have questions about that at all, please be sure to reach out for some help. I am happy to help you, and let's move on. All right, so we've talked about the inside measures, right? The inside angles all add up to 180 degrees. Now, you're sometimes going to get pictures of triangles that look like this, where you have a triangle, but then you also have a line kind of extending out from the triangle. So you can see right here that I have this line that continues, and if we look, it forms this angle, which in this picture is labeled angle 1. Now, there's a kind of shortcut to solve for the measure of angle 1. And the way that you can do that is you take the two angles that aren't touching it. So that would be angle A and angle B. And if you add them together, it equals angle 1. Now, sometimes students will make the mistake of using this angle right here. But do you see how this angle touches angle 1? You can't use an angle that touches angle 1. You have to use the two other angles, which are actually called remote angles because they're not close to it, okay? So let's practice some problems with that. We have, in the beach chair shown, the measure of angle 2 is 55 degrees. Okay, so we know this is 55. And the measure of angle 3 is 60. And we want to find the measure of angle 1. So in this case, angle 2 and angle 3, they don't touch angle 1. So if I just say the measure of angle 2 plus the measure of angle 3, that would equal the measure of angle 1. So 55 plus 60 equals 115 for angle 1. So you'd say the measure of angle 1 equals 115. And that's all you'd have to do. You just add those two angles together and you are good to go. Why don't you go ahead and solve for this one? We have in the roof frame shown, suppose the measure of angle 2 is 25 degrees, the measure of angle 3 is 45 degrees, and I want you to find the measure of angle 1. Good luck. Okay, for this problem, hopefully you said 25 plus 45 equals 70, so the measure of angle 1 is 70. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. And let's move on to our last example for today. In the figure, we know that the measure of angle 4 is 135 degrees. 135. We want to find the measures of angle 2 and angle 1. So if we look at this problem, I see that the measure of angle 4 is supplementary with angle 1. But some of you might be thinking about how we just practiced solving for those exterior angles, right? We said that those exterior angles, so in this case the measure of angle 4, would be equal to the measure of the two angles that are not touching it. So in this case, the measure of angle K plus the measure of angle L, or sorry, angle 2. So the measure of angle K we know is 90, plus the measure of angle 2 we don't know, but the measure of angle 4 we know is 135. So it's still using that same formula, but we're going to solve for it a slightly different, it looks just a little different than the last example we did. So we would say 135, and then you would just subtract 90 from both sides. So the measure of angle 2 equals 45. Okay, so we have the measure of angle 2 equals 45. And then we have a couple different ways that we can solve for the measure of angle 1. You either can say that it is supplementary with angle 4, or you can say that they're 180 degrees in a triangle. So if we do the 180 degrees in a triangle, I would say the measure of angle 2, which we said was 45, plus 90 plus angle 1 equals 180. So 45 plus 90 is 135, plus the measure of angle 1 equals 180. So notice that when I did that, I got something that would be the same way as solving if we just treated them like they were supplementary, right? Because I would say the measure of angle 1 plus 135 equals 180. So it doesn't matter which method you choose, they will both give you the correct answer. So then the last step we have to do is just subtract 135 from 180. So the measure of angle 1 equals 180 minus 135, which is 45 degrees. Okay, so then I'd say the measure of angle 1 equals 45. And just so you know, angle 1 and angle 2 in a picture like this won't always equal 45. All right, now this is the last one for you to solve. I want you to solve for the measures of angle 1 and angle 2. Notice it's the same picture, but you're going to get different answers because we're given a different angle. We're told that angle 5 is 147 degrees. All right, so go ahead and solve for angle 1 and angle 2. Good luck. Okay, so in this problem, I first solved for the measure of angle 1 using 90 plus angle 1 equals this exterior angle. So when I did that, I got 57 degrees for the measure of angle 1. And then to solve for angle 2, I treated these as just supplementary angles. I said the measure of angle 2 plus 147 would equal 180. And I subtracted from both sides, and I was left with the measure of angle 2 equals 33 degrees. So that is everything for today's lesson. If you have questions about either this problem or anything else in the video, please be sure to reach out for some help. I am happy to help you. I hope you have a great day.